my recording. Yeah. So the next talk will be given by Adan Gomez on computational representation of a cognitive control mechanism for a goal-based executive function of a cognitive system. So Adan, I think you can set it up.
Okay, can you hear me?
Yes.
Okay, excellent. Let me share my screen. Okay. Hi, everyone. This presentation is titled Design of a Cognitive Control Mechanism for a Goal-Based Executive Function of a Cognitive System. This study is the first attempt to create a cognitive approach for an educational tool in the nursing program of the Universidad de Córdoba, Colombia. This study is the first stage of a research project that is executed in that university. Thus, it will be presented the design of a cognitive process of control for the health of a computational system based on a specific mechanism that we have called goal-based executive function. For that reason, this study lacks its empirical findings, and it is in the design stage. My presentation is structured like that. First, I will present a theoretical background about executive functions and cognitive control. Second, I will describe a formal representation of the cognitive control mechanism used in the system and its computational representation. Next, an illustrative example will be shown, and finally, the conclusion of the study will be presented. First of all, executive functions is the set of necessary skills for resolving purposeful, goal-directed activities. Some of them are anticipation, goal selection, planning, initiation of action, self-regulation, mental flexibility, attention deployment, and feedback utilization. Executive function incorporates multiple interrelated high-level cognitive processes as an integrated supervisory or control system for information processing, formulating goals, planning, self-monitoring, and self-regulation. Solving complex real-world situations require cognitive processes oriented to improve the system efficiency. These processes, called cognitive control, include working memory, management of attentional resources, control unexpected and erroneous responses, and monitoring of mental states. And executive functions is a set of cognitive processes used to develop a specific action. According to Caro in 2014, this type of function is a functional element that allows information processing to achieve the system objectives. On the other hand, Quechlin and Sommerfeld developed a model based on concepts from information theory to describe how executive function can be subdivided into hierarchically ordered control processes, each responsible for selecting an action on the basis of information that is successively more remote in time. There are several theoretical approaches of self-control. This type of model I explained in the previously presentation. I'm going to explain again this model. Quechlin and Sommerfeld in 2007 presents a theoretical approach of self-control as simple routines for selecting actions or selecting goals. The approach measures the amount of information required for each process using the statements of information theory. We implemented this approach computationally in goal-based mechanism. For this reason, the objective of this study is to present a model of executive function using a cognitive control mechanism. This approach is based on information theory to determine the total amount of information required for selecting an action through the the equation h of a equal minus log base to the probability of a, where the probability of a is the relative frequency or probability that action can be selected. And you can see the another equation for the cognitive control. Anderson in 2002 presented a model about the executive functions. For this author, executive functions are multiple process-related systems that are interrelated, interdependent, and function together as an integrated supervisory or control system. Thus, in his model, Anderson conceptualized executive function as 4 distinct domains. First, attentional control. Second, information processing. Third, cognitive flexibility. And fourth, goal setting. These executive domains are discrete functions that are related to specific frontal systems. Nevertheless, they operate in an integrative way to execute a specific task, and together they can be conceptualized as an overall control system. In this study, we try to simulate only 2 processes of this model, self-monitoring and inhibition. Now I will describe the formal representation of cognitive control mechanisms function based on theoretical approaches of Anderson in 2002 and Quetelet and Sommerfeld in 2007. Thus, a cognitive control mechanism for a goal-based executive function is a 5-tuple. Epsilon C represents the cognitive control goal-based executive function. S is the stimulus, read by the function from algorithmic knowledge profile stored in a cognitive buffer. O is the output of the executive function. C is the signals to execute cognitive control. G is the goal to be achieved by the function. Chi is the expectation of the system. The figure presents the functional structure of a goal-based executive function, where executive processes composed by actions send the information obtained from input to a cognitive buffer. This buffer encodes information in traces, which are constantly monitored by a cognitive monitoring mechanism. This cognitive buffer acts as a working memory. When control conditions are related to the stimulus received by the executive functions, the cognitive monitoring mechanisms encode the specific trace associated with that stimuli. The cognitive control mechanism receives the processed trace from the cognitive monitoring mechanism. This last mechanism can detect errors in the executive process's cognitive actions and set goals considering current goals and expectation of the system. In these slides, a cognitive system about basic concepts of gestational and congenital syphilis is presented as an illustrative example of the previously described model. This system is an initial version in the Spanish language that has not been tried yet in a student's sample. The system will be used in the nursing program of the Universidad de Córdoba, Colombia in the next future. The figure presents the system's output after executing an executive function that selects an educational resource for a specific lesson of the system. In this case, the system considered the student's performance, interaction history and score, rendimiento del estudiante, de interacción y calificación de recurso in Spanish language, as cognitive control conditions for selecting the resource. The chosen resource was a flow graph. You can see in this portion of the image about the incidence of congenital syphilis in Córdoba, Colombia. This figure shows a record of the activity of the student in the system. This record allows identifying some aspects in which the system has used its ability to control the cognitive actions for selecting resources. For example, the student named Samuel Moreno had 2 attempts, intentos en español, in Spanish language, for achieve a score, rendimiento in Spanish, of 100% in lesson 3. However, the system chose 4 resources in that 2 attempts. Here can be observed that the cognitive actions of the executive function selected a photo, fotografía in Spanish, but the control mechanisms changed that resource by an interactive video interactivo in Spanish, considering the control conditions previously described. You can see the record here, but in Spanish language. In the same way, the resource called video class in Spanish, was replaced by a timeline, línea de tiempo in Spanish. It can be observed that the student obtained a score of 100% in a time considerably less than the previous times. This situation could happen thanks to the changes done by the system, considering the cognitive control stored in its procedural memory. Because the study is in its design stage, we haven't empirical findings. These results is a first attempt of implementation of the cognitive control mechanism previously described. Currently,
Hey, Adan, this is your 5-minute reminder.
Thank you, right. Currently, we are doing different type of tests for proving the effectivity of the mechanism in the performance of the system. To sum up, this paper presented a new approach for the use of cognitive control mechanisms based on biological-inspired theoretical approach. This model is about the Anderson in 2002. A formal computational representation are presented in a summarized way. Mechanisms use a goal system and a procedural memory for developing the setting goal processes. An illustrative example is described presenting the output data of the system. These results enable to have a new approach to build cognitive systems based on theoretical and empirical assumptions inspired in biological models. However, it is necessary to continue developing cognitive systems that use multiple instances of cognitive functions in one or many reasoning cycles to solve real-world problems. That are the reference used in the study. Thank you so much.
So I have one question. So yeah, so you have not presented any empirical results. I just wanted to learn how you plan to do that going forward.
Could you repeat me the questions, Raya? Sorry.
Yeah, so I was just wondering how you would like to direct this work to include the empirical results. I mean, how would you do that?
Okay. We can make mechanisms into the system using different type of algorithms like deep learning or machine learning, especially in the area of the cognitive processes. This type of function can use different type of algorithms depend of the necessity of the system in that moment. I think that is the possibility that we can use to do that.
Thank you.
Thank you.
And so yeah, if you have any other questions, again, please look out for the Slack, and yeah.
Okay.
So yeah,
Thank you.
thank you.